Yes. Yeah, now, okay, am I visible?
No, sir.
Okay, 1 minute. Yes, now it's working. All right. So let's continue from this question. The question is, which of the following solutions will not make the bulb glow? Say if I were to take a sodium chloride or copper sulfate or silver nitrate or sugar solution, which one of them will not make this bulb glow?
D1.
Do you know that is sugar solution? Very good. Okay. Now this question. Okay, Roni is also here. Khadija is also. I didn't notice. Yes, how are you guys? Roni and Khadija. Good.
Good, sir.
All right. Okay. By the way, you guys also have a look at this question. Roni and Khadija. All of you turn your cameras on in the class now. Quickly answer this question. Okay, Roni. Khadija, by now you must have got your syllabus for the upcoming exam now, and Roni, you also would have got your syllabus for the upcoming exam. Yes. Yes, Roni, that is correct. Khadija, you also answer this question. You have sodium chloride. Sodium chloride is basically the common salt, no? NaCl, the common salt that we consume at home. Copper sulfate is CuSO4. Silver nitrate is EgNO3, that is silver nitrate. So sugar solution, industrial water, which one? By the way, you guys just give me 1 minute. Actually, I have to add one video in the slide. I wanted to show that video to you guys. Okay, now? Just hold on for 1 minute. Okay. Just 1 minute. Okay, see, uh, as we were learning about the various uses of electrolysis now, one of the important use of electrolysis was that it can be used to break down compounds. It can be used to break down the compound into its constituents, right now? So as I was saying that you guys can carry out this experiment at home also. Okay, now by taking some precautions, okay, by wearing some safety gloves and specs, you can do this at home also. So what you can do, just have a look at this video. This man have explained how via the process of electrolysis, water can be broken into hydrogen gas and oxygen gas. Okay, now just have a look at this. And he has used almost whatever material he has used now, almost all of them would be available either in the nearby shops. Some of them you can get it from the laboratory or get it from a chemistry shop. Okay, now the shops that would be selling the laboratory equipments. So just look at this. That's the starting of the video. Now he has taken some water, 2 test tubes. Now he has taken these batteries and he is taking out the carbon rods. Okay. Now he's connecting those carbon rods with a battery. We'll be connecting it with the battery. And notice how he's dipping those carbon rods into the test tube, inside the test tube. And notice he added something in the water. He added some acid in the water, some water from the battery. Notice the bubbles coming out from the electrodes. Just let me pause over here. Notice the bubbles, no? Okay, now you guys keep this in mind, like why he took some drop of water from this battery. You know, battery water contains acid, no? Sulfuric acid is found in the battery water. Remember, if you guys were active in the class, if you guys would have paid attention, so there one of the use was, use of the acid was that I did told you that acid is used. Okay, that was in different class, by the way. Yeah. See, in the class 7th, there you would have studied about use of the acids. In the chapter acid, bases, and salts, there you guys would have learned that sulfuric acid is used in manufacturing the car batteries. Okay, now, so that's why he took some acid from the car battery or like any other battery that would be usually available at our home. So all the things are usually available except for the glass beaker or the test tube. Okay. Now, continuing from here, as he added the acid and as he connected the battery, then see what will be happening once he connects the battery. Bubbles starts to form right over here. See, the bubbles are forming right now because we know that due to passing of the electricity in the electrolyte, the acidified water will break into hydrogen and oxygen gases. Right now, hydrogen will be the basically it will be H plus ions and this one will be O minus ions. This will be the positive ion, this one will be the negative ions. Okay, continuing further. Observe here. Hydrogen gas being positive, like hydrogen ions being positive, will be attracted towards the negative electrode, that is cathode, isn't it, guys? While oxygen ion being negative, it will be attracted towards the positive electrode, that is anode. This should be clear, a basic thing. Is that clear to everyone?
Yes, sir.
Notice further how he will be collecting those gases now. The gases, namely hydrogen and oxygen gas, that is accumulating in these test tubes. He will collect them and then he will, let's see what he does next. Very carefully he took out those test tubes, making sure that the gas does not comes out of it, does not gets leaked. So what do we observe here? What happened to this? Just anyways, basically the thing is now, in the beginning, as you have seen that, as he brought a lighter near to this, so this immediately caught fire, as you can see, right? This immediately caught fire. So if it immediately catches fire without producing any sound, so that will be the hydrogen gas. And if it catches fire but also produces a pop sound, then that will be a hydrogen gas. Getting it, guys? If it catches fire without producing any sound, that will be oxygen gas. If it produces sound with a little pop sound or little bit of explosion, so that will be the hydrogen gas. So I hope you guys have understood this, why this activity. In the previous slide, I did told you guys that I will be showing that video. Okay. Let's continue from here. Khadija, you didn't answer this one, by the way. Okay, Ronnie, you haven't got the syllabus yet. Okay. So this question was which of the solution will not make the bulb glow? So
Sir,
all of them,
sugar solution.
exactly, sugar solution. No? Very good. Okay. Continuing from here, I'm going to assign the questions. There are 4 questions here. So first one, Roni, Gauri, then Khadija, you. Okay. And this one, anyone can answer the last one. Yes, Roni. The object to be electroplated is taken as? Is it taken as the cathode or is it taken as the anode? By the way, all of you turn your cameras on in the class now. Yeah, that is correct. Also, you have to answer in the class only. Like once the questions have been assigned, then no need to answer in the chat box. Anyways, that is correct. So the object to be electroplated is taken as cathode electrode. That is the cathode. Yes, Gauri.
Sir, is it electrolysis?
That is electrolysis. Very good. But it is talking about the application now. Electrolysis is the process. Electrolysis is a process. Okay, no, not an application. Try to understand it. Electrolysis, it's a process of splitting of a compound of an electrolyte into positive and negative ions when electric current passes through it. So it's a process. But talking about application, we have? Yes? Anyone else? Guys, we have learned about various applications of electrolysis. Didn't we learn about various applications? What were all these things? What was this electroplating? Hmm? Isn't it this? Is this not one application of the chemical effect of electric current? Electroplating, basically, right? We did learn about electroplating. That is the most common effect of chemical, most common application of chemical effect of electric current. Then we did learn about purification of metals also. Purification of metals also. We did learn about this. Right now, we did also learn about we did also learn about decomposition of compounds like that. So that will be electroplating. Okay, Gauri.
Okay, sir.
Yes, next.
Sir, conductor.
Conductor of electricity. Very good. The last one, anyone can answer. Gauri, you answer the last one. Okay, let's assign it to Gauri.
Sir, iron.
Why you will be electroplating iron on a tap water or a cycle bill? Will iron be giving you a shiny appearance?
No.
In fact, it will corrode. It will catch rust. No. Others can also answer this. Yes, Khadija, Roni, and Gauri.
Sir, chromium.
Exactly. That is chromium now. Okay. That is chromium. Like over here, we can look at the chromium. Chromium is used in certain machines to electroplate certain objects. Okay. We did that question. Now continue from here. Why is a layer of zinc coated over iron? Khadija, would you like to answer this one? Roni, you answer this one, the last one, and Gauri. Yes, one of you start answering.
Sir, answer of third one is heating effect.
Exactly, that is heating effect. Very good.
Sir, I'm not sure.
No worries, go on.
Like, I don't know the answer.
Okay, you don't know the answer for the first one. Okay. By the way, Roni, your answer is correct. That's good, by the way. Okay, I think Roni, your mic is not working. Thereby, you are answering in the chat box only. Anyways, see, why a layer of zinc will be coated over iron? Anyone would like to answer this?
Sir, to prevent rusting.
To prevent it from rusting, na? See, actually, na, what the problem is, like an iron object is is when an iron object is exposed to moisture, if it is in contact with moisture now, with air and water, then a layer of rust will develop over it. Like this is a pure iron, for example, that is Fe. Over time, what happens? This iron will be reacting with oxygen and it will be reacting with water. So thereby, a layer of rust will form above the iron body, and that will be Fe2O3 dot XH2O. This is basically rust. That brown structure that you see over the certain over old iron gates or old iron objects, na, that rust is basically iron oxide. So the thing is, na, iron will eventually react with oxygen and water when left, when it is left in the open. If it is not painted or if it is not covered with a layer of zinc or other less reactive metal. So iron is very reactive. It will react with oxygen and water. So thereby, there are some metals which are less reactive. So how about we apply a coating of a less reactive metal over the iron? So thereby, iron will not get rusted. Its durability will increase over time. So zinc is coated over this via the process of electroplating, right now. And that process is called as, particularly when coating of zinc is done over iron, what do we call that as?
Galvanization.
Galvanization. Very good. Okay, now you guys read this question. One of you please read the question quickly. So what could have been the reason? Like after adding one more cell, the bulb started to glow. Yes. What do you guys think? Let me drop a reminder for Chakrika, by the way. She also is supposed to be joining the next backup class. Okay, now. So just let me drop a message for her to the team. Meanwhile, you guys answer this question.
So what's the timing of backup class?
Right after this class ends, your backup class will start.
Okay, sir.
Okay, na? So you'd be only requiring backup class for the chapter pollution of air and water then only, because synthetic fiber that has been removed right now.
Yes, sir.
Okay. Yes, what happened to you guys? Yes, Khadija, Roni. See, Bujo made an electric circuit as in given in this diagram. She took a bulb, she took some wire, she took some cell and dipped those in this electrolyte right now. So when she used only one cell now, as the question says that on Paheli, the bulb was not glowing right now. So Bujo made the circuit, but the bulb was not going. So Paheli suggested her to add one more cell in the circuit. Okay, now there could have been one or two cells. So Paheli suggested to add one more cell, and what she observed that the bulb glows. So the obvious reason is that the magnitude or the strength of the current would not have been sufficient to make the bulb glow. Getting it now? It might not have been sufficient. Getting it,
Yes,
guys?
sir.
So that is the reason for this. So initially, the bulb did not glow because the magnitude of the current flowing in the circuit was not sufficient. But after adding one more cell, the strength of the current increased. Hence, the bulb glowed. That is one thing. Okay. Now here we have another. We have this question. Remember, in the class we did learn about electroplating of copper over brass. Right now, we did learned about this one. No? How electroplating of copper is done over the brass. This one,
Yes, sir.
not this one over here. I think. Mm, Where did that diagram went? Over here. Okay, now over here you can see, yeah, this one actually. We did learn about electroplating of copper over the brass, and we did learned about various things like why a certain electrode has to be, which electrode has to be taken as cathode, which one has to be made the anode, right? Now, so we remember that the material over which coating has to be done, that is always made the, yes, that is always made
cathode.
no, and the another one is the anode basically. Okay, so keeping that in mind, you guys read this question first of all. Yes, Khadija, do one thing, read the question.
Paheli wants to deposit silver on an iron spoon. She took silver nitrate solution in a beaker and set up a simple circuit for electroplating. Which terminal of the battery should be the spoon be connected to? What material should
Material.
the other electrode be?
Hold on for a minute. Yeah. So in the question, what we observe, like basically, Paheli wants to do a silver plating over this spoon. Okay, now this is an iron spoon. So obviously, things that needs to be kept in mind while you are required to do a coating of silver over an iron object, like an iron spoon. So we have taken an iron spoon in the setup, you can see. Another one is the silver strip, basically a pure silver strip, silver material has been taken here. In the electrolyte, we have made sure that the same metal is also available. Silver is also available in the electrolyte because that is one of the criteria for electroplating, that the metal which has to be coated now, the electrolyte should also have the same metal, right? So we have taken silver nitrate. That is silver nitrate. Okay, now that is so far. Furthermore, we have learned the material over which electroplating has to be done. Right now, like here, it is a spoon. So that is always connected to the negative terminal of the battery, and thereby that will be cathode, isn't it?
Yes, sir.
Right, Khadija and Roni and Gauri? So answer
Yes,
the
sir.
question, simple question. In fact, I have already answered it. So what's the answer to this? Yes. What's the answer to this, guys? Which terminal of the battery should the spoon be connected to?
Negative.
Negative terminal. Very good. Okay, now. And the other electrode should be made up of? The other electrode,
Silver.
obviously it should be silver, no? Okay. Can you guys tell me why the silver should be attracted towards the spoon? While electric current will be passed, why the silver should be attracted towards the iron spoon, I mean to say? Yes. Yes, Gauri, Khadija. There seems to be some issue with my camera today. Uh, it's working now. Yes, you guys didn't understood the question. Like my question was why silver would be attracted towards the iron spoon? That was the question, why it would be attracted towards the iron spoon. First of all, you know the spoon has been made cathode, so thereby it is negatively charged, right? While the silver has been made anode, so this is positively charged. Upon passing of the electricity, what happens? The silver nitrate, it will be breaking up into Ag plus and NO3 minus ions, namely positive and negative ions, right? Also, this silver present in the anode, that will also start to dissolve in the electrolyte. So silver will also start to come out of it. We know that silver being positively charged, silver ions being positive, so it should be getting attracted towards which electrode? Should it be the negative or the positive electrode?
So can you repeat?
Silver, like when electric current is passed into this electrolyte, so thereby silver nitrate is going to break into positive and negative ions, namely silver and nitrate ions. Also, the silver from the anode, that will also start to dissolve in the electrolyte. So silver ions being positively, it should be getting attracted towards which electrode? Should it be getting towards cathode or the anode?
Cathode.
What happened to others? Khadija, you not getting it? And Roni, answer it honestly if you guys are getting it or not. Gauri, you have answered it
Sir, I
correctly,
didn't
by
get
the way.
it.
Not getting it. See, Roni, what about you? You can answer in the chat box. Guys, what we learned now, whenever electric current is passed, or basically whenever electrolysis takes place, so the electrolyte splits into positive and negative ions. Okay, it splits into positive and negative ions. Also, we have learned when electroplating is done, so the material over which coating of another metal has to be done. Now, like this is the spoon over which silver has to be plated. So this will always be connected to the negative terminal. Okay, now so it becomes cathode. So it is negatively charged, while the other one will be positively charged right now. So moments ago, as I said, that silver nitrate will be broken into positive and negative ions. So this positive ion, that is silver, by the way, Ag is the symbol for silver. Okay, na Ag, it's the symbol for silver. Okay, na in short, this is how silver is written. Getting it, guys? So silver will being positive, it should obviously get attracted towards the oppositely charged thing, that is this cathode. Now, as you have learned in the case of magnets, like charges repel each other, unlike charges attract each other. Same thing is applicable for charges also. Opposite charges attracts and same charges repels each other. So that is the concept here. Getting it, Khadija? Good.
Yes, sir.
All right. So that is the thing. So here we have completed this chapter, and now we're going to continue with the next chapter. And as per the syllabus, Alif is also absent today, no? Okay, Khadija, you haven't got your syllabus as of now?
No, sir.
Not yet. Okay. So after observing the syllabus of the students, the syllabus which the students have shared, like Aleph, Chakrika, and Gauri. So on the basis of that, the next chapter which we're going to begin now will be some natural phenomena. Okay, this is the chapter which we are going to continue with. And I suppose all of you be having this chapter in your book. See if this chapter has been removed by your teacher, or will this chapter or is will this chapter is there in your syllabus or not? Because from the updated syllabus, it has not been removed. This is in the in this year's syllabus. This chapter is there. Okay, no. So let's continue from this chapter, some natural phenomena. Before I continue, can you guys tell me like what are some natural phenomena? Huh? What are some natural phenomena that we observe?
Sir, earthquake,
Earthquakes are there.
thundering,
Thunderstorms are there. Good.
Tsunamis?
Tsunamis are there. Very good. And tornadoes, right? Tornadoes are there. And what else?
Floods?
Floods are there. Very good. Landslides are there. Right now, landslides are there. Floods are there. Tsunami, earthquake, volcanic eruptions as well. Right now,
yes, sir.
volcanic eruptions also. So in the chapter, some natural phenomena, we would be mainly talking about different kind of phenomena. Like some of the phenomena, as you guys have mentioned, we'd be learning about that. But first of all, we would be learning about lightning. Okay, now we'll be learning about lightning, like what lightning is, when the phenomena of lightning was from a scientific perspective, when it was studied for the first time. when it was discovered for the first time that lightning contains charges. Okay, now there was a person who discovered for the first time that lightning contains charges in it. So we'll be learning about that. Furthermore, okay, Chakrika is in the class. Furthermore, you'd be learning about some other natural phenomena like while we'd be learning about lightning, now we would be learning about how we can charge objects, like by rubbing the different objects we can charge them like that. Okay, yes, Chakrika, how are you? Okay, furthermore, in the chapter, after learning about lightning, how lightning occurs, why sound is produced during a lightning, getting it now, what is the reason behind that. So those things we'd be learning about that. Okay, now how we can produce charges, right? How different charge objects would be interacting with each other. What are the different types of charges? Like you have positive charge and negative charges. How the charges would be interacting with each other. Like charges would be repelling while unlike charges would be attracting each other. Hmm. Then we'd be learning about how charges can transfer from one body to another. Getting it now? How flow of charges will take place, how electricity flows. Hmm. Then we'd be learning about some special objects like what is an electroscope, huh? Why earthing has to be done in the home. Okay, good, Chakrika, no issues. Yes, I'm also good. By the way, Chakrika, see the previous chapter, chemical effects of electric current, that has been finished, and we have started the chapter some natural phenomena. This chapter has been started. Okay, and also today for you and for Gauri, extra class has been scheduled for the chapter pollution of air and water. By the way, Khadija and Roni, you guys also do let me know, like if those chapters are these chapters have been done in your school or not.
No, sir.
No. Okay, Roni, what about you? Was this chapter done in your school? Pollution of air and water? Not yet. Okay. Also, this chapter is not in everyone's syllabus. It was a chapter. This chapter is now removed from the updated syllabus, but still in some of the schools it is being taught. So, Chakrika, will you be available for the extra class today? Do let me know in the chat box. Okay. So we'd be learning about different kind of things. Also, you would have observed like earthing will be done right after this class. There will be a backup class. Right after this class, when this class ends, there will be a backup class. Okay, Chakrika. You guys would have seen like a earth wire would be okay. It will be available. Good. Of you would have seen like a earthing wire would be there in your houses. Have you guys seen that? Like either from a very either into the in the pillar of the house, uh, a wire would be connected to the pillar of the houses, for example. Or basically, we will install a earthing rod in our houses to protect our houses from lightning. Getting it, guys? So we'd be learning about what lightning is, why it is done. uh, what are the safety measures one has to take place if there's a thunderstorm, if there's a lightning nearby, what are the safety measures one should take place, one should take care of. Then later on, we'll be learning about earthquakes. Okay, na? Or how earthquake develops, what is the cause behind the earthquakes, what are the different types of earthquakes based on their magnitude. How do we measure earthquake? Like you would have learned about, have would have heard of Richter scale. Hmm? What is the Richter scale? What are seismograph? What is the use of seismograph? Hmm? Furthermore, what are the protective measures we can take against earthquake? How earthquake-proof buildings are nowadays being manufactured? And so, what is the principle behind that? So, all those things we are going to discuss in the chapters in this chapter. All right, now these are the things we should be learning in the chapter. Okay, but before that, let us start. Let me just give you the content of the chapter. What are the things we are going to learn in the chapter? Okay, now. So all of you give the write down the chapter's name in your text copy in your copies, and write down the content of the chapter. Okay. First of all, write down the content of the chapter. All of you. Yeah, sure. Yes, Roni. So first topic, give the first topic to be discussed as electric charges. Okay, electric charge. So we'll be learning about electric charge. Who was the first person to have discovered the electric charge? Should be learning about this. We'll be learning about charged bodies. We'll be learning about uncharged bodies right now. How a body can be charged by friction, by rubbing. How an object can be charged. So all those things we'll be learning in the topic electric charge. All right, now all those will be the subtopics. The main topic is electric charge. Under this, you'll be learning about different things. Okay. Then you'd be learning about types of electric charge. Types of electric charge and interaction between electric charge. How they will be interacting with each other. Okay, now how they were going to interact with each other with the help of some activities you'd be especially learning about them. Right now, like you will have seen, like a plastic comb would be attracting pieces of small papers, right? So why attraction takes place between them, and why not a repulsion takes place between them? So we would be learning about that. Later on, we'd be learning about a very special instrument, a very special device called as electroscope, which you guys can even make at home. Okay, no? You'd be learning about this. What this device is basically, it is a device that is used for detecting whether electric charge is present on a given object or not. All right, now so we'd be learning about this. Furthermore, we'd be learning about some other concepts in the chapter. We'd be learning about lightning, by the way. Lightning. Okay, so we will learn about this. Like you would have seen, the bright flash of light in the sky. So why does it occur? Okay, now why the lightning occurs? We'll be learning about these things. In this, we'll be learning about what are the dangers of lightning. Like when lightning would be striking the earth, it can cause lots of destruction. It can damage properties. It can damage the buildings. It can damage trees. Getting it now? It can even kill the peoples. It can even kill the people. Getting it? So what are the then safety measures which we have to take care of in order to protect ourselves, or in fact in order to protect our building also? So thereby a lightning conductor will be installed on the top of buildings. So we'll be learning about that also. Okay, now so the main topic is lightning. Under this, there are going to be several subtopics which we are going to discuss. After this, you'll be learning about earthquakes. We'll be learning about earthquakes. Okay, now earthquakes basically trembling or shaking of the earth that occurs usually for a short period of time. In earthquake, now while we'll be learning about this, first of all, we will learn the causes of earthquakes, and we will also look at does human activities can it also lead to earthquakes? You'd be learning about that also, like can human activities on Earth trigger earthquake? Okay, now in fact, studies suggest that there's a rare chances, but if we were to do some heavy construction activities in a particular area, if the terrain of that area is disturbed, so it can trigger earthquake in that area. We'll be learning about that. Also, earthquakes can trigger other natural phenomena. Like earthquakes can also lead to flood, it can lead to tsunami, it can lead to landslides also. Getting it, guys? Also, have you guys did you guys heard of the Bhuj earthquake? How many of you have heard of the Bhuj earthquake? BHUJ, the Bhuj earthquake that occurred in Gujarat in the year 2005. Okay, let me give you the recent example. Recently, all of you know. Okay, recently you would have heard like an year ago there was an earthquake in Turkey. Yes, you guys have heard of that?
Yes, sir.
Huh? So earthquake in Turkey claimed lots of life. Okay, there was a huge loss of life and property there. Should be learning about
Sir,
this. Yes.
wasn't there an earthquake in Japan?
Recently in Japan, yeah, Japan is known to have most of the earthquakes. Right now, they are the maximum number of earthquakes occur in Japan. By the way, okay, no.
But what's the reason behind it?
Actually, the area, the plate over which Japan is lying now, those plate regions, they would be continuously colliding with each other. As we know, the Earth, the lithosphere is made up of different plates. Now, continental plates are there, oceanic plates are there, right now. You would have learned about like Eurasian plate, Asian plate, American plate, etc. So you'd be learning about that. There, well, while we would be learning about the structure of the Earth now. So we'd be learning about the structure of the Earth. Like Earth is namely made up of three main layers: the core, the mantle, and the crust. So the crust, that is the uppermost part of the Earth now, the outermost layer of the Earth. It is made out of different plates, right now, different plates, and it would be kind of floating on the mantle. Just think of it like this. For example, you have a cup of water, you have a cup of water, and if you were to drop something on it, like let's say you drop a piece of ball or some foam, so that object will be floating on the water, right now. So the crust basically is kind of floating on the mantle. They are floating on the mantle. So mantle is not liquid like water, but it's a semi-solid layer of the earth. Getting it? It's semi-solid. So this is mantle and this is crust, and the crust would be kind of floating over the mantle. This is crust. This is mantle. The layer right beneath the crust, that is called as mantle. So the crust will be kind of floating above the mantle. So they are also, we know crust is not one single piece of land mass. Crust is divided into so many plates. So those plates will be colliding with each other. And the place where they will be colliding with each other, huge amount of energy will be released. And as a result of that, the they will be trembling on the surface of the earth. Getting at what I'm trying to say?
Yes, sir.
Okay. So the places on Earth, like for example, this is a plate and this is a plate. These are two plates and they are colliding with each other. They can either collide with each other. At some places, the plates would be moving away from each other. At some places, they would be colliding with each other. So if a country happens to be situated over here now or over here, so most of the earthquakes would be happening at that place now, where the plates would be colliding, where they would be meeting. Getting it now? So places that would be situated in such region would be more prone to earthquakes. So we'd be learning about that in detail. Okay, moments ago I was talking about the Bhuj earthquake or the recently earthquake in the Turkey an year ago. It claimed I think 40 or 50,000 people died, I think, in that. Okay, so it can be really destructive, very destructive. Okay, in fact, so many countries had to provide aid, provide food and other medical support to Turkey. Okay, now so we'd be learning about why earthquake occurs right now. So we'd be learning about that in detail. Furthermore, we'd be learning about seismic zones. What are the seismic zones? We'd be learning about a seismograph. Okay, now also in India, we know that certain states in India are more threatened to earthquakes, like the northernmost part of India, like the Kashmir. Kashmir or the states in the eastern state of India like Assam or Arunachal Pradesh or Meghalaya or Mizoram or Tripura. Those are the states that are more prone to earthquake. Why is it so? What is the reason behind that? Getting it now. Furthermore, parts of India like in Rajasthan or parts of India lying in the Indo-Gangetic plain, they are more prone to earthquake. Okay, now it is less likely, like earthquakes are less likely to occur in southern states like in Tamil Nadu or in Kerala or in Andhra Pradesh or in Karnataka. Getting it, guys, what I'm trying to say. Also, you guys tell me, like most of the news of earthquake that you see, you'd be seeing it coming like the you'd be hearing it from like the northern states of India, like in near to Delhi, for example, in Uttar Pradesh, like that. Getting it, guys. So we would be learning about those things. Then we'd be learning about the working of the seismograph. What a seismograph is. Okay, no? What is Richter scale? Huh? Who invented the Richter scale? Getting it? So that's all you guys have to study in the chapter. If anyone has any doubt regarding the chapter, please let me know. Yes, Khadija, Chakrika, Gauri, and Roni. Okay, shall we begin then? Okay, let's start the class then. Let's start the chapter. So talking about electric charge. So talking about electric charge, we know that even before this, there are a few other things to be discussed. Like for example, in your previous class, you guys would have studied the chapter of wind, storm, and cyclone. Yeah, wind, storm, and cyclone. You guys would have learned about that chapter, no? Chakrika, you were there in the 7th class, no? You would have learned about the that chapter of wind, storms, and cyclones. Others would also have learned, right, Roni, Gauri, and Khadija?
Sir, I didn't.
Okay, no worries. Maybe that chapter might not have been in your syllabus, in your school syllabus. Okay, no? Anyways, so in that chapter, now basically it is taught that the various things are taught in that chapter, like how cyclones are very destructive natural phenomena, how it can cause lots of damage to human life, to the property. We also learned, uh, some of you would have also learned that what are the protective measures one has to take against cyclones, right? Now, like although like if although we can't stop the cyclones, but with timely action we can minimize the damage. Okay, now we can minimize the damage caused by the cyclones. Getting it, guys? If people were to evacuate from that area on a proper time, right, before the cyclone hits that area, then the damage can be minimized to some extent. So in this chapter we are going to be learning about some special phenomena, like we'll be learning about lightning and earthquake in particular. Okay, now we will be learning about what are the ways using which we can minimize the destruction caused by lightning and earthquakes. All right, now that is one thing. So before we go on to discuss we go on to discuss electric charge or types of electric charge. First thing is talking about lightning now. Talking about lightning. Lightning is basically it's a electric spark taking place on a huge scale. You all would have seen electric sparks sometime. Huh? If there's a short circuit in the power circuit board or in the main power supply board, that gives a spark. So you can think of lightning as a spark taking place on a huge scale. Getting it, guys? So in the case of lightning, what happens? In the case of lightning, what happens? When huge amount of charges will be accumulating in the clouds, when huge amount of electric charge will accumulate in the cloud, so thereby lightning will be observed. Okay, now? So, so that is the thing. And electric charge is basically the property of any given matter which is responsible for a electrical phenomena. Right now, Whatever kind of electric phenomena we see, whether it be lightning or whether it be flow of electricity taking place in the wire, all of that takes place because of electric charges. Got this? What I'm trying to say. Also, in the previous class, we have learned about charge particles, right? We have learned about charge particles. We did learn about how charge particles would be formed, right? Roni, Gauri, Chakrika, and Khadija. We did learn that whenever there is some external disturbance, so thereby the number of electrons in a given particle can either increase or decrease. So that will disrupt the atom, and hence it can either become positively charged or negatively charged. So electric charge would be of two types. One will be positively charged, another one would be negatively charged. Okay, no? So let's continue from the topic electric charge. First of all, we are going to learn a little bit of history about this, okay? So talking about the history, almost about 2500 years ago, there was a Greek scientist by the name of Thales. There was a Greek scientist by the name of Thales. So about 2500 years ago, there was a Greek scientist. There was a Greek scientist by the name of Thales. Let us understand what this person did. What was his contribution? Okay. So Thales, what he observed now, he observed that when a material known as amber was rubbed with a silk cloth, it started attracting tiny fibers. You all know what a resin is? Do you guys know about resin, a product that comes out of the bark of the trees?
Yes, sir.
You know about that, no? It would be yellowish and golden color, having a golden color. Look at this structure, the one that you see over here. This one. Okay. Also, you know, initially it will be coming out from the bark of the tree in the form of a liquid, but upon time, after some time, it will become very hard. It solidifies. Okay, now this is what amber is. Okay. So the thing is that what this person observed, that when this amber was rubbed with silk cloth, so it started to attract tiny feathers. It started to attract tiny feathers. So this is resin or basically amber. Okay. So when this is rubbed with silk, so what did he observe? That amber started to attract tiny feathers. Amber started attracting tiny feathers. So what could have been the reason behind this? Huh? As per Thales, what he said, that amber acquires electric charges or electricity by rubbing with silk. As per him, he said that electric charges are acquired by the amber. It becomes charged. Thereby, then it attracts tiny feathers. Getting it now? And the force of this electric charge, the force of the electric charge will make it attract tiny feathers. Right now? So due to rubbing with silk cloth, it acquired some charges. And now it started to attract the feathers. So about 2500 years ago, charges were discovered for the first time by Thales. So hope that is clear. Apart from this, also you guys can do several simple activities to show that charges exist. Can we see charges around us? Is it a visible thing?
Yes.
In certain situations